In this section, we'll be talking about real-world applications in trigonometry. These questions usually involve an object moving from highest point to lowest point and back to highest point again. So if we map it out, it will look like a cosine curve. And secondly, starting at a point and moving upwards and downwards. So if we map it out, it will look like the sine curve. If you represent it as a trigo graph, you can find the constants a, b, and c easily. So a, b, and c will usually be in an equation like a sine b t plus c or a cosine b t plus c. You can just take t as another variable in replacement for theta. Usually the questions will ask you to find the constants a, b, and c. For a, it will usually be known as the radius in the question or the amplitude, which can also follow the formula of the maximum value minus the minimum value over 2. Secondly, to get your b, it will be identified in the question as time for one revolution or time for one cycle or anything along that meaning. Now this time for one revolution will also be known as the period, and you'll use this formula period equals to 2 pi over b, and therefore b equals to 2 pi over the period. And finally, to get c is just how far the graph is from the x-axis. For example, this is our original sine curve, where it starts at 0. However, if we shift the sine curve upwards by, let's say, 2 units, then our c will be represented as 2. So this is our c. C also follows the formula of maximum plus minimum value over 2. Now let's move on to the examples. A water wheel rotates 5 revolutions anti-clockwise in 1 minute. Tom starts a stopwatch when the bucket B is at its highest height above water level. The radius of the water wheel is 8 feet and its center is 5 feet above the water level. Since the water level is being taken as the reference point, we will take our water level to represent our x-axis. The height of bucket B above water level is given by h equals to a cosine bt plus c, where t is the time in seconds since Tom started the stopwatch. Part 1. Determine the value of a, b, and c. A, if we recall, is also known as the radius. The question did specify the radius of the water wheel being 8 feet. That's why our A just equals to 8. Secondly, if you recall, C is how far the graph is from the x-axis. So since we are taking our water level as the x-axis, it's mentioned in the question that the center is 5 feet above the water level. So it's 5 feet away from the x-axis. That's why our C is also equals to 5. Lastly, we need to find our B. So for B is not as straightforward, but they did tell us in the question that it rotates 5 revolutions in 1 minute. Since the question wants us to solve in seconds, we need to first convert the 1 minute into seconds. So 5 revolutions equals to 1 minute, which is 60 seconds, and 1 revolution is just 60 over 5, which is equals to 12 seconds. From here, we can plug in our formula of period equals to 2 pi over b. Now we know that our period is equivalent to the duration it takes to complete 1 revolution, which is 12 seconds over here. So subbing it in, 12 equals to 2 pi over b. B will be equals to 2 pi over 12, which is equals to pi over 6. That's how we get our b. And then we are done with part 1. For part 2, for how long is h less than 0? What does this mean? Looking back at the diagram, if we are taking the water level as the x-axis, h is less than 0 when the circle is under this water level. From here to here. This is when h is lesser than 0. Therefore, we will need to find this value and this value, which are the x-intercepts. Summing back our values of a, b, and c, we'll get h equals to 8 cosine pi over 6 t plus 5. Then to find the x-intercepts, we'll let it equals to 0. Bring the 5 over and dividing it by 8, we'll get cosine pi over 6t equals to negative 5 over 8. Now from here, if you recall, when your cosine is equals to a negative number, we cannot directly cosine inverse the negative number. Instead, we need to find our basic angle first. And then we'll use our ASTC to derive which quadrants that our angle is in. So to get our basic angle, we'll do cosine inverse of 5 over 8, which gives us 0.896. Now if we draw out our ASTC, A and C are the ones that will give us a positive value because it's cosine, right? So we don't want those. We want the quadrants that will give us a negative sign. Therefore, it is in quadrants S and T, which is quadrant 2 and quadrant 3. Therefore, we'll use pi minus 0.896. This is to find the angle in the second quadrant, and pi plus 0.896, which is to find the angle in our third quadrant. Therefore, we'll end up with these two values of 4.29 and 7.71 as each of our x-intercept. Then, since the question is asking for how long, the duration that h is lesser than 0, we need to find the difference between these two x-intercepts, which is 7.71 minus 4.29, equating to 3.42 seconds. Don't forget the units. Part 3. Explain what does the answer in part 2 mean. Basically, they are trying to ask you to relate your part 2 answer into the context of the question. So the question is talking about a water wheel, right? And less than 0 means that it is below the water level. Therefore, part 2 answer basically means that the bucket is submerged underwater for 3.42 seconds. Okay, the last example. A buoy floats and its height above the seabed, h meters, is given by h equals to a cosine b pi t plus c, where t is time measured in hours from 0-100 hours, and a, b, c are constants. The least height of the buoy above seabed is 180 meters and is recorded at 0-100 hours. The greatest height above seabed is 196 meters and is first recorded at 600 hours. Find the values of A, B, and C. So as you can see, it's not as straightforward as the previous question. So let's try solving for B first. Now the question tells you that at 0-100 hours, the buoy is at the least height above the seabed, so it starts at the bottom. And then after 6 hours, it will reach its maximum height. When you draw out in the graph form, it will look something like this, which if you kind of imagine, it looks like half of a cosine curve. So you know that this is half a cycle, because the question did specify that it follows a cosine graph shape. Therefore, half a cycle equals to 6 hours from 0-100 to 600 hours, so from 12 am to 6 am. Therefore, one cycle equals to 6 times 2 hours, which is 12 hours. And from there, we can identify our 12 hours as one period. Now, plugging it back to our formula, period equals to 2 pi over b. So 12 hours equals to 2 pi over b, and b equals to 2 pi over 12, which is pi over 6. However, the question already specified that the expression of h has a pi here. Therefore, b is just pi over 6 divided by pi, so you just get 1 over 6. Next, we can find our A. So if you recall, the formula for amplitude is also maximum minus minimum over 2. And looking at the question, they did tell us the maximum and the minimum value. So the least height and the greatest height at 180 and 196 meters respectively. So we can just sub that into our formula, 196 minus 180 over 2, and then you get 8. However, it doesn't stop there. When the cosine curve goes from lowest to highest, it also tells you that it has a negative A, because a positive cosine curve looks like this. But when it goes from lowest to highest, you'll see that the curve is now upside down. This is a negative cosine curve. Therefore, the sign of A has to be a negative sign. So we just add a negative sign in front of 8 and you get our A, negative 8. Lastly, we can find our C. C is the middle value of the lowest value and the highest value. So basically you can find it by doing maximum plus minimum over 2. And using the same maximum and minimum values as given in the question, we'll get 196 plus 180 over 2, which is equals to 188. So that is our C. So therefore, we'll have A equals to negative 8, B equals to 1 over 6, and C equals to 188. Part 2. Using the values found in Part 1, sketch the graph of H and note that the range for T is 0 to 24. Let's start off with sketching the axis first. We have H as our vertical axis and T as our horizontal axis. Starts at 0, ends at 24. We have found previously in part 1 that one cycle equals to 12 hours. Therefore, from 0 to 24 hours, we'll note that there are 2 cycles happening, so there will be 2 cosine curves. We will also note that at 0-100 hours, the height of the boy above seabed is 180. So the cosine curve will not start at negative 1, unlike our usual cosine curve. Instead, it will start at 180. It will start at 180, peaking at 196 and coming back down to 180. And this concludes our first cycle. So here it will be 12. Then we can draw our second cycle, which is the same cosine curve ending at 24. Now when our cosine curve reaches the maximum of 196, this occurs when t equals to 6 and 12 plus 6, so 18. 6 hours after the second cycle starts. Finally, we can mark a horizontal line, dotted line, which is our original x-axis. So this is how our graph will look like. Part 3. The boy floats above the top of a huge rock first at 500 hours, so 5 a.m. State the number of hours in each day that the boy is above the rock. Now if we look at this graph, when t equals to 5, it is 1 hour before 6. Therefore, the same level will happen again when t equals to 7 due to symmetry in the cosine curve. Now to visualize it easier, I'll draw a dotted line cutting across the value of h when t equals to 5. So t equals to 5, you trace up, you cut here, and now I draw a dotted line cutting across this value. You'll see that it touches the curve 3 more times. Here, here, and here. Due to symmetry, the distance between 5 and 6 will also be equals to the distance between 6 and the next t value, where the graph is being cut again. And likewise for in the second cycle. Therefore, this height is achieved when t equals to 5, 7, 17, and 19. And we can now find the duration that the ball is above the rock. So duration is just represented by this whole distance plus this whole distance. That's why it's 7 minus 5 plus 19 minus 17, which is 4 hours.